In this video, we're going to discuss unit conversion. So some important thoughts. We want to pay really close attention to units that you're given in problems. It turns out that many of the problems that we've done can be altered in some way, shape, or form to give us values that aren't necessarily in equal units. Particularly if you think about the last video that we watched about measurement, I could have some shape that maybe one of the lengths is measured in feet and the other one is measured in a decimal of a mile or something like that. Or one's measured in centimeters and for some reason the other one is measured in inches. Well, then obviously that inconsistency can create problems for us. So we want every unit when we're measuring, when we're calculating, to be on equal footing. We want them all to be represented in the same way so that we calculate things properly. So this becomes something really important to us. We want to make sure that we have those units that are equivalent when we're given a problem. And if we're not, then this is the steps that we're going to take to make sure that everybody's on the same field. So important things, of course, we can't add or subtract numbers with different units. So I can't just add 12 feet and 4 inches to call that some 16 feet inches or something like that. However, I can use these values when I want to multiply. So I can multiply numbers with different units in a way. It just we need a conversion factor in there in order to do that, to allow things to cancel. And so this is where we get into the idea of a conversion factor. So a conversion factor is a ratio of two equal values. I'll give you an example. This one right here actually would have been a nice one to talk about. Um, if I want to convert maybe 12 feet to inches, or 4 feet to inches, for example, what I need to do is I need to find a conversion factor, or I need to make a ratio that gives me a relationship between feet and inches. Now I know that 12 inches is equal to 1 foot. And so my conversion factor can be written one of two ways. I can write it with 12 inches on the top and 1 foot on the bottom. Or this is the same thing as saying 1 foot on the top and 12 inches on the bottom. And so when I have it in this form, it just depends on how the setup is prior to me using this, or what unit I'm trying to cancel in order to determine whether I should be using this conversion factor or I should be using this conversion factor. So let's talk about the example that I just wrote down, going from feet to inches. 4 feet, if I start with that, then I'm multiplying by a conversion factor where I want the feet to cancel out and be on the bottom. So this problem originally was just given to me with 1 unit. I can make this a fraction over 1, and that tells me that this unit that I was given in the beginning is on the top. If I want this unit to cancel out, then I'm going to put the same unit on the bottom, and now I allow these to cancel. So of the two conversion factors that I was writing down here, the one I would want to use for this problem is the first one. I'm going to put 1 foot on the bottom because feet cancel out, and therefore I need 12 inches on the top. This is what allows me to multiply together. When my feet values cancel out, I'm only left with 1 unit, that's inches, and I am allowed to multiply these numbers together. So 4 feet is the same thing as saying 48 inches. We can do the same thing in these other problems that work on time. We start out with 5 days. Again, I make this a fraction over 1. Before we go through this process, it may be useful to write out the conversions that we use to go from days to seconds. Off the top of my head, I don't know how many seconds are in a day, but I know how many hours are in a day, and I know how many minutes are in an hour, and I know how many seconds are in a minute. And so the process of converting is going to go like this: days to hours, hours to minutes, minutes to seconds. Which means we're going to need lots of conversion factors in this problem. But if we do it one conversion factor at a time, it won't get so overwhelming. The first conversion factor we want to use is the one that goes from days to hours. I'm labeling this as conversion factor number 1. If I want to go from days to hours, and I already have days on the top, my conversion factor needs to have days on the bottom, which means I'm going to put hours on top. Then I need to find the relationship between hours and days. Well, I know that one day, you don't need to put the S there, is the same as 24 hours. At this step right here, days and days cancel out. I can multiply these across if I want to, if I'm ready, and my final answer would be in hours right now. But I don't want to stop at hours. I want to keep going. So I'm going to go from hours to minutes next. My next conversion needs to have hours and minutes in it. And because I have hours on the top here, the hours unit is going to go on the bottom, and the minutes unit is going to go on the top. I know a relationship between hours and minutes, that 1 hour is equal to 60 minutes. At this step, my hours units cancel out, and if I multiplied across, my final answer would now be in minutes. I have one more conversion to make, and that's to go from minutes to seconds. Again, because I have minutes on the top, I want my minutes unit to be on the bottom, which means I'm going to put my seconds unit on the top. I know that 1 minute is the same thing as 60 seconds, so this step here, my minutes unit cancel out, and my final answer will be in seconds. To multiply these across, what I prefer to do is multiply all of the numbers on the top first, and then write my answer, and multiply all of the values on the bottom, and write my answer, and then divide those. In this particular problem, there's not much to it because all of the denominators are 1, and anything divided by 1 is just itself. But on the top, we're going to multiply 5 times 24 times 60 times another 60. And we get 432,000 over 1, which is just 432,000 seconds. So 5 days is 432,000 seconds. We'll do some other examples here. Here's a nicer, easier example. It tells us to convert 60 inches into feet. Remember, we already discussed there are 12 inches in 1 foot. It's a great place to pause the video and practice this one on your own, and then we can do it together. So we know 60 inches by itself is a fraction over 1. We're going to make another conversion factor over here, and it's going to have inches on the bottom and feet on the top. We know the relationship that 1 foot is equal to 12 inches, so we're ready to multiply. Our inches units cancel out. On the top, I have 60 times 1, which is 60. On the bottom, I have 1 times 12, which is 12. 60 over 12 is 5. Let's do this one here. Use the following conversions to find out how many cups are in 5 gallons. So, our starting value is 5 gallons, which we can always write as a fraction over 1. And now we multiply. We're going to go from gallons to quarts, gallons on the bottom, quarts on the top. It tells us the conversion here that 1 gallon is 4 quarts. Then we're going to go from quarts to pints. I have quarts on top. I want my quarts on the bottom so that they cancel, and I can convert from quarts to pints. It tells me that 1 quart is 2 pints. And then lastly, we're going to go from pints to cups. I have pints on top, so I'll have pints on bottom. 1 pint is 2 cups. And now I'm ready to multiply. gallon unit cancels, my quarts cancels, my pints cancels, and the only one left I have is cups. When I multiply across, 5 times 4 is 20, times 2 is 40, times 2 more is 80, over 1, which is just 80 cups. We do one more example before we're done, and that uses the unit conversion table here. Do one unit conversion problem here. We have a chart. It's kind of funky to read, but what I will say is you can use it. You can either read it either direction. I prefer to choose a value over here in the row first, and then look at the conversion to what it is in the column. So I'll give you an example, and that's how we build, by the way, and this chart is how we build our conversion factors. One of the conversion factors will have a numerator or denominator of 1, and then the other one will have some decimal value attached to it, depending on if we're getting bigger or smaller. So let's try this example first. We're going to go $100 US to 100 British pounds. So we'll start with 100. I'm just going to use USD right here for US dollars. Remember that anything can be written as a fraction over 1. Our starting value in these will always be written as a fraction over 1. Then we'll multiply by some conversion factor. And again, because we have US dollars on the top, we're going to put US dollars on the bottom. We're going to put British pounds on the top. Now we want to find a relationship. We know right here, according to using this chart, USD and GPB, I can choose these elements right here, that 1 US dollar is equal to 0.61 British pounds. When I multiply this together, it tells me that $100 is the same thing as 61 British pounds. Let's put GBP. We'll do one more. Let's see, which one do we want to do? We have converting 100 US dollars to our Japanese yen. We start out with 100 USD. Over 1. We know the relationship between US dollars and Japanese yen is that 1 US dollar is equal to 104.413 Japanese yen. We multiply these together. We're going to move our decimal place 2 to the right. And we get 10,441.3 Japanese yen. That's it for unit conversion. You may have some monetary conversions. Also, some time conversions are usually really good on the exam. There is a section in here that has more challenging examples. I don't foresee anything like that ending up on your exam, but they're great practice and preparation for Math 120. And that's it.